welcome to my channel Chemistry is Fun. Today we will continue with the chapter solutions, which is meant for class 12 and CBSE board. We have already started the topic solubility of a solid in a liquid. Today we will see the effect of temperature and pressure on this solubility of a solid in a liquid. First we will deal with effect of temperature. Now see, the solubility of a solid in a liquid is definitely affected by temperature changes. And this is a dynamic equilibrium, so it will definitely follow Le Chatelier's principle. If there is a nearly saturated solution, then the dissolution process is endothermic and the solubility increases with rising temperature. But on the other hand, if it is exothermic, the solubility decreases, and these have also been observed experimentally. Next we see the effect of pressure. There is no significant effect because solids and liquids are highly incompressible. Pressure does not have much significant effect because the solids and liquids both are highly incompressible and they are unaffected by the changes in pressure. Next we will see solubility of a gas in a liquid. There are many gases which dissolve in water. Oxygen dissolves to a small extent, and because of this dissolved oxygen only, all aquatic life is sustainable. But there are certain other compounds like hydrogen chloride gas. It is highly soluble in water. And we find that the solubility of gases in the liquids is affected by pressure and temperature. The solubility of gases usually increase with increase of pressure. Now see, if we have a system, as we can see here, the lower part is solution and the upper part is gaseous system. The pressure is P and the temperature is T. We first assume that the system is in a state of dynamic equilibrium. Means the rate of gaseous particles entering the solution and leaving the solution is the same. That is, entering the solution and leaving the solution. Both are same. Now if we increase the pressure of the solution by compressing the gas to a smaller volume, as we can see here. Now here what we have done? We increase the pressure over the solution. So because of this, what happens? There is increase in the number of gaseous particles per unit volume over the solution. In this much area, you can see there is an increase in number of gaseous particles per unit volume. So the rate at which gaseous particles are striking the surface, so that will also increase. The rate at which gaseous particles are striking the surface to enter it, that will also increase, because the number of gaseous particles per unit volume has increased. So what will happen? Because of this, the solubility of the gas will increase until a new equilibrium is reached. Next we have to see what we term as Henry's law. Now see, this law states that at a constant temperature, the solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of the liquid or solution. The solubility of a gas in a liquid is directly proportional to the partial pressure of the gas present above the surface of liquid or solution. So he concluded that the solubility of a gas in a liquid is a function of partial pressure of the gas. It is a function of the partial pressure of the gas. And the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. So Henry's law is also stated in this way: the partial pressure of the gas in vapor phase is proportional to the mole fraction of the gas in the solution. So this can also be expressed in a mathematical way. P is equal to KHX. KH is the Henry's law constant. We are taking mole fraction as X and the partial pressure of the gas in vapor phase P. And X we have taken as mole fraction of the gas in the solution. Here KH is the Henry's law constant. Different gases will have different KH values at the same temperature. So we can say that KH is a function of the nature of the gas. I hope students you all could understand the topic which I discussed today. Thanks for watching my video. Please share the video and subscribe to the channel. Thank you.